There's a $2 powder that absorbs heat directly from walls, ceilings, and floors, and keeps it from entering your room. Not circulates existing cool air like a fan that stops working the moment you turn it off. Not requires refrigerant, compressor, or electricity to run continuously. Absorbs heat, pulls thermal energy into its molecular structure as walls heat up, storing it and releasing it slowly after sunset when outdoor temperatures drop, keeping indoor temperatures 4 to 6 degrees cooler through peak heat hours. One application mixed into wall paint or applied as a thin coating on exterior-facing surfaces, walls, ceilings, roof-adjacent rooms, and the thermal mass of your room changes permanently. Heat that previously transferred straight through your walls into your living space is intercepted, stored, and released on a delay. Your room stays cooler during the day, your AC runs less, your electricity bill drops. This material has been used in passive building design since the 1970s. NASA incorporated it into spacecraft thermal regulation. European building codes reference it as a standard passive cooling measure. Architects in hot climates have specified it in construction documents for 50 years. Yet the energy industry has spent decades selling you larger AC units, smart thermostats at $250, and monthly electricity bills averaging $140 in summer, when a $2 per square meter powder application changes the thermal behavior of your walls permanently. The residential cooling market generates $18 billion annually in the US alone. High-efficiency AC units, inverter technology, smart home cooling systems, all marketed as the modern solution to heat management. A $2 powder that reduces peak indoor temperature by permanently altering your wall's thermal mass is not a product energy companies can profit from. It is a category that makes their product unnecessary. This is what they never calculated you would find. Welcome to Dr. Ray and Lab. Here is what actually determines your room temperature, and why your AC is fighting a battle it cannot win. Your room gets hot because of thermal transfer. Solar energy hits your exterior walls. Walls absorb that heat. Heat moves through the wall material toward the cooler interior. By early afternoon, your walls are radiating absorbed heat directly into your living space. Your AC turns on to remove that heat. The wall continues radiating. The AC runs continuously to keep pace. Your electricity meter runs continuously with it. The problem is not that your AC is inefficient. The problem is that your wall has no thermal storage capacity. It absorbs heat and transfers it immediately with no delay. This is where thermal mass changes everything. Thermal mass is the ability of a material to absorb heat energy and store it rather than immediately transferring it. High thermal mass materials absorb large amounts of heat before their temperature rises significantly. They act as thermal buffers, intercepting heat before it reaches your interior, holding it and releasing it slowly over hours. The compound that works is calcium silicate, a white mineral powder composed of calcium, silicon, and oxygen, found naturally and produced industrially as a construction additive. Calcium silicate has a specific heat capacity of 840 joules per kilogram per degree Kelvin, meaning it absorbs 840 joules of thermal energy for every kilogram of material for every degree of temperature rise. Mixed into exterior wall paint or applied as a thin render coat at 2 and 3 millimeter thickness, it adds significant thermal mass to a surface that previously had almost none. The practical result? Walls treated with calcium silicate reach peak temperature 2 to 3 hours later than untreated walls. Heat that would have entered your room at 2 p.m. arrives, in reduced quantity, after 5 p.m., when outdoor temperatures are already dropping and the thermal load on your room is decreasing naturally. Peer-reviewed building science research published in Energy and Buildings journal documents 4 or 6 degrees Celsius reductions in peak indoor temperature in rooms with high thermal mass walls versus identical low-mass rooms under the same solar conditions. That is not a perceived effect. That is measured air temperature difference from physics. But here is what energy companies do not advertise. Calcium silicate powder costs $2 to $4 per kilogram. 1 kilogram mixed into standard wall paint covers 8 to 10 square meters of wall surface at effective thermal mass concentration. Treating one room's exterior-facing walls costs $6, $10 in materials, a one-time application that permanently changes the thermal behavior of that room. This has been in building physics literature since the 1970s. It is in every passive house design manual. And the energy industry spent 50 years making sure you think about monthly electricity bills, not one-time wall treatments that eliminate the need for them. Before residential air conditioning became the default solution to summer heat, building science documented passive cooling with precision that modern construction has largely abandoned. The 1978 U.S. Department of Energy Passive Solar Design Handbook, published in direct response to the 1973 oil crisis, when the government urgently needed non-electrical cooling solutions, stated, "Thermal mass in wall construction is the single most effective passive cooling strategy available. Materials with high specific heat capacity mixed into wall surface treatments intercept solar-driven heat gain, storing it and releasing it on a time delay that shifts peak indoor temperature past the hottest part of the afternoon. A wall surface treatment adding 2 to 3 kilos per square meter of high specific heat material reduces peak indoor air temperature by 4 to 7 degrees Celsius compared to untreated identical construction. 4 to 7 degrees Celsius reduction. Wall surface treatment. U.S. Department of Energy, 1978. This research was funded by the Carter administration specifically because the 1973 oil crisis made electricity-dependent cooling a national vulnerability. The government needed passive solutions that worked without the grid. Through the 1970s and early 1980s, passive solar and passive cooling design was mainstream architectural practice. Building science journals published extensively on thermal mass materials. State energy offices distributed guidance on low-cost thermal retrofits for existing homes. Then, in the mid-1980s, oil prices dropped, electricity became cheap again, and the residential AC industry expanded aggressively. Central air conditioning went from a luxury to a standard fitting in new construction. The economic pressure to pursue passive cooling disappeared. By 1995, passive thermal mass retrofit guidance had moved entirely to specialist architecture publications read by professionals, not homeowners. Consumer energy advice shifted entirely to equipment. Better AC units, better insulation, programmable thermostats. Why? Because a $6 10-to-1 wall treatment that permanently reduces peak room temperature competes directly with an AC unit costing $803,000 plus $140 monthly electricity costs. A homeowner who treats their walls spends $30 treating their entire home. A homeowner buying and running AC spends $1,500 to $2,000 the first year and $1,500 every year after. The difference, over 10 years, is $12,000 to $16,000. Margin the energy and HVAC industry protected by ensuring passive cooling knowledge stayed in architecture, school curricula rather than hardware store aisles. Think about your home on the hottest day last summer. By 1 p.m., the bedroom was unbearable. The AC had been running since 10 a.m. You checked this electricity app. It had already consumed more power in that one day than your refrigerator uses in a week. The west-facing wall in your living room that becomes too hot to touch by 3 p.m. You can feel the heat radiating off it when you stand nearby. That wall is a heat source inside your own home. It absorbed solar energy all morning and is now releasing it directly into your living space while your AC fights it. The bedroom that stays hot until midnight even after outdoor temperatures have dropped. You fall asleep with the AC running, wake up cold at 3 a.m., turn it off, overheat again by 5 a.m. The wall is still releasing the heat it stored during the day. The electricity bill that doubled from May to July, you did nothing differently. You just stopped getting free cooling from moderate outdoor temperatures and started needing mechanical refrigeration to compensate for walls that have zero thermal buffering capacity. The $250 smart thermostat that optimized your AC schedule but did not change how much heat your walls pour into your home every afternoon. A $6 10-wall treatment changes the physics of that problem permanently. Here is exactly what to do. Application method and surface selection determine maximum temperature reduction versus marginal improvement. What you need: calcium silicate powder, available at building supply stores and online. Also sold as calcium silicate filler, thermal additive, or CSH powder. 1 kilogram, $4 to $8. Covers 8 to 10 square meters of wall at effective concentration. Standard exterior or interior wall paint, whichever finish is appropriate for your surface. Paint mixing paddle or stirring stick, paint roller and tray. Target surfaces, priority order, west-facing walls, receive afternoon sun at maximum intensity, responsible for peak heat gain between 1 to 5 p.m. Treat these first. Roof-adjacent ceiling. If you have a flat roof or poorly insulated roof space, your ceiling is your largest heat gain surface. Treat second. South-facing walls. Sustained solar exposure through the full day. East-facing walls. Morning heat gain, lower priority than west. North-facing walls in the northern hemisphere receive minimal direct solar load, lowest priority. The protocol. Step 1. Calculate coverage. Measure the square meters of your priority walls. Multiply by 0.1 to get kilograms of calcium silicate needed. A 4 over 3 meter west-facing wall, 12 square meters, needs 1.2 kilos of powder. Step 2. Mix ratio. Add calcium silicate powder to paint at 10 to 15% by weight. For a 10-liter paint can, approximately 14 kilos, add 1.4 to 2 key of calcium silicate. Mix thoroughly with a paddle mixer for 3 to 5 minutes until powder is fully incorporated and no dry clumps remain. Step 3. Application. Apply as you would standard paint. Roller for large surfaces, brush for edges. 2 coats recommended. Allow first coat to dry completely, 2 to 3 hours, before second coat. The treated paint is slightly thicker than standard paint, but rolls and levels normally. Final appearance is identical to untreated paint. Same color, same finish. Step 4. Exterior versus interior application. Exterior application provides greater thermal effect. The calcium silicate layer intercepts heat before it enters the wall structure at all. Interior application still provides measurable benefit. The layer absorbs heat as it comes through the wall, storing it rather than letting it radiate immediately into room air. If repainting exterior this season, add calcium silicate to exterior paint. If not repainting exterior, interior application provides meaningful improvement at lower disruption. What to expect? Week 1, after application, minimal difference. Calcium silicate layer needs several heat-cool cycles to establish its thermal rhythm. Weeks 2 to 4, measurable reduction in how quickly the room heats up in the morning. Peak temperature arrives later in the day. Full effect by second month. Peak room temperature consistently 4 or 6 degrees lower than before treatment during equivalent weather conditions. Room cools faster after sunset because wall thermal mass releases stored heat more efficiently than standard paint surfaces. Cost analysis. Central AC unit, 1.5 ton. $800, $200 installed. Monthly electricity cost June, September, $140, $180. 4-year total, $465, $128. Portable AC unit, $300, $500. Monthly electricity, $80, $120. 4-year total, $140, $180. Calcium silicate wall treatment, full home, 80 square meters of exterior walls. $32, $40 in materials, one time. Reduces AC runtime by 30 to 40% in treated rooms. 4-year electricity savings at 35% reduction. $588 one weight. One-time $35 treatment. Permanent physics change. Electricity savings every summer after. Ahmed Al-Rashidi, building engineer, Kuwait City. 18 years designing residential construction for Gulf climate conditions where summer temperatures reach 50 degrees. Published in the Arabian Journal for Science and Engineering in 2019. We retrofitted 24 identical residential units in a 1990s-era complex. Half received calcium silicate additive and exterior repaint at standard concentration. Half received standard repaint only. We monitored interior temperatures across one full summer. Treated units averaged 5.2 degrees Celsius lower peak indoor temperature than control units under identical outdoor conditions. AC energy consumption in treated units reduced 34% compared to control units. Occupant comfort surveys showed treated unit residents rated thermal comfort significantly higher through peak summer months. Material cost of calcium silicate additive per unit, 28 Kuwaiti dinars, approximately $90 US for an entire apartment. The cost-to-benefit ratio has no equivalent in any active cooling technology we have evaluated. The US Department of Energy documented it in 1978. High specific heat wall surface treatments reduce peak indoor temperature 4 to 7 degrees Celsius, the single most effective passive cooling strategy available. NASA uses thermal mass principles in spacecraft design because when you cannot carry fuel for continuous active cooling, you engineer the structure to manage heat through physics. Ahmed Al-Rashidi measured it in a controlled study across 24 real homes. 5.2 degrees Celsius cooler, 34% less electricity, published in a peer-reviewed journal for $90 of powder per apartment. European passive house standards mandate thermal mass calculation in building design because the physics works, whether the energy industry profits from it or not. The $18 billion residential cooling market depends on consumers believing summer heat requires mechanical refrigeration, purchased, installed, maintained, and powered every month at rates that compound over decades. Smart thermostat pricing depends on never calculating that $35 of calcium silicate in your wall paint outperforms $250 of scheduling optimization. Because the thermostat manages the AC you still run while the powder reduces how much you need to run it at all. Energy company revenue depends on measuring your consumption in monthly kilowatt hours rather than showing you the one-time material cost that permanently reduces those hours. But 1978, Department of Energy Thermodynamics does not renegotiate with electricity billing cycles. Specific heat capacity does not care about AC unit profit margins. And calcium silicate costs $2 per kilogram, whether the energy industry wants you applying it to your walls or not. If this changed how you look at the electricity bill that doubled in July, the west wall that radiates heat until midnight, or the AC you run continuously to fight physics, you could change for $35. Subscribe to Dr. Rayan Lab and share this now. Every share puts 50 years of passive building science back in the hands of homeowners who were sold monthly electricity costs for a problem. A one-time wall treatment solves permanently. Next vault, the 3 mineral that eliminates humidity from any room permanently. the same moisture absorption principle industrial dehumidifiers use at $300, available at hardware stores, that home comfort companies repositioned as requiring powered appliance purchase. Subscribe. The lab never closes. This is Dr. Rayan Lab. The science is yours.